Today's video is sponsored by Figure Markets, the largest non-bank mortgage lender in the US with over 15 billion unlocked on their lending platform. They've just lowered rates on their Bitcoin and ETH-backed loans even more to 8.91%, which is 9.999% APR, improving their already industry-low fixed-rate 50% LTV loans. They keep building as well, having also just launched decentralized MPC custody, the only place to get that amongst the major loan providers, and removed interest deferral fees entirely. What is MPC decentralized custody, you might ask? Well, it's a Bitcoin or ETH on-chain wallet with multiple key shards to protect you from a single entity custody failure. You can always see your crypto ownership in a segregated wallet and verify your collateral hasn't moved. Whether you're funding a major purchase, like a down payment on a home, investing in new opportunities, or even buying more Bitcoin, Figure makes it straightforward and transparent. Visit their app or click my link below to take out a Bitcoin-backed loan with Figure today. Let's get some facts. 37% of you aren't subscribed to this channel. That's almost 4 out of 10 just freeloading the alpha. So come on, hit subscribe and I promise to keep leveling up the show with the best guests and the juiciest insight. Go on, do it now. Hi, I'm Raoul. Welcome to my show, The Journeyman. The Journeyman, as you know, is when I travel to that nexus of understanding between macro crypto and the exponential age of technology. Now, I try and cover as many different component parts of this, the macro, the crypto, and the exponential age. And obviously, front and center of a lot of this right now is AI. Not only is it changing how economies work, but it changes how literally everything works. And so we need to stay on top of the changes. One of the big battles we've been facing in crypto is that world of decentralization versus centralization, but that battle's everywhere. And it's also in AI. Decentralized distributed AI is an important part of where the future lies. You see, we can't concentrate such power, such superpowers with a few firms. So I really wanted to speak to somebody who knows more about that particular topic and where the world is going. So I'm speaking from Jeff from Nous Research to really dig into what the world of decentralized AI looks like and open source AI. So I hope you enjoy it. And quickly before you go, today's episode is brought to you kindly by Figure Markets. If you're looking for the best way to unlock your crypto's liquidity, Figure is the largest non-bank mortgage lender in the US, with over 19 billion unlocked on their lending platforms. Explore their industry-low crypto-backed loans at 8.91% interest rates and a 50% LTV. They differentiate themselves by offering decentralized MPC custody, which protects your crypto ownership in a segregated wallet. Liquidation protection, which protects you from liquidations during large price drops for both Bitcoin and ETH. Whether you're funding a major purchase like a down payment on a home, investing in new opportunities, or even buying more Bitcoin, Figure makes it straightforward and transparent. Visit their app or click on my link below to take out a crypto-backed loan with Figure today. Anyway, let's go and catch up with Jeff from Nous Research. Jeff, fantastic to get you on Real Vision.
Yeah, I'm really honored to be here.
I'm really looking forward to this conversation. Some mutual friends at Delphi Digital said, you've got to speak to these guys. And I'm like, okay, if that's what you say, then I must. So tell me a little bit about your journey. How did you get to where you are?
Yeah, I sort of had a circuitous journey to this particular place. I spent a while in automotive, actually here in Detroit. So I live in Detroit, Michigan, and I spent the first 15 years of my career basically working on automotive electronics. So in your car, there's all these computers that connect your engine and all these other pieces, and I worked on that. And so I was sort of around AI in its old fashion, or I guess you call it machine learning at the time, right? Starting with and really pushed by driverless tech, which, has always been interesting because if you go back and you read these science fiction stories, driverless autonomous cars were the first thing, obviously, that would happen. And it was funny that this is still the hardest thing almost one of the hardest things to solve, But anyway, that was sort of the first wave of old school machine learning, after AlexNet. And so I was around it because the company I was at, our customers were actually the engineers at places like General Motors, at Tesla and stuff like that. So I sort of saw it. But hadn't really touched it at all, in my own work, and so was around it, and then about 4 years ago, something called Stable Diffusion came out, and Stable Diffusion.
Ahmed Mustak is a friend of mine.
Yeah, okay. So And so I remember I was sitting there, I think it was over Christmas break or something like that, and I saw it and I was like, whoa, like this is, I could tell, you get one of those moments where like you've had a step change. This was one of those moments where I was like, okay, here we go. And basically what I did is I walked away from the job and did everything and said, I have to learn everything there is to learn about this. I'm one of these guys who's super technical and wants to be able to step through the code. And the fact that this was like open source, you could download it and like I could not step through it. Now you get to this point when you're stepping through the code where there's the magic call the AI, do the forward pass. And, that's a lot more opaque than I was used to as like a developer, but really being able to step through and touch this and run it on my GPU, my gaming GPU that I'd just been sitting around. I was like, there's something happening here. And so once that, became apparent, I essentially did everything I could to learn everything I could about the tech. And that was what brought me to the point of doing open source AI research, just anonymously, really. On Reddit, on Twitter, on Discord, met up with a group of people, and we sort of all had this vision that we wanted to be able to keep happening, where you could run this AI, these open source AI systems on your own machine. You could step through them. There would be no one who could control it. If you wanted to modify it at all, you could do it. And unfortunately, the industry itself is a very centralizing force. We've seen all these gigantic amount of capital that's being brought together at these different companies, and that's a centralizing force. So we founded this organization called Nous Research to be like, how can we keep open source and decentralized artificial intelligence at the frontier level?
How does decentralization work in this space? Because of the massive demands of compute and everything else for the training of the models and stuff like that. How are you approaching it?
Well, that's really the thing is you need a hack, or you need like something that's like going to get around all this. And I actually, I spent, when I did my master's at Michigan, and I actually studied Zcash, which was this cryptocurrency that it's still around actually.
It's become very popular.
Yeah, it's doing very well all of a sudden. It was very not cool or interesting 10, 12 years ago. But it was interesting to me from a academic perspective, right? And that's how I got introduced to cryptocurrency. It was really more as an academic, really. I was studying the privacy functions because, again, to me, the interesting piece of it was how did Zcash itself keep your transactions private?
Yeah.
And through that, I sort of became aware of crypto, from an academic perspective. And so what I was around it all the time, but I hadn't done too much with it. And when we founded Noose, I was looking at them like, how are we going to find some step function that's going to allow us to, get out of this trap of having to go raise, look at companies like OpenAI having to go to sovereign wealth funds, to like raise their capital. Like you need some sort of hack about that. So we said, okay. So we said, is there a way we can use these decentralizing technologies to fuel the growth, not only just really from a capital perspective, but also from a decentralization perspective? Because again, that was our ethos. The thing that was important to us was how are we to keep frontier open source intelligence existing when there are all these centralizing headwinds. So using crypto rails really gives us two key pieces. One is the capital formation, but the second is the true decentralization. So right now, when you do a normal training run, you have one single data center, right? That's like built, and it's all controlled by a single entity. What we work on is tech that allows us to do training across multiple data centers, multiple GPUs all over the world. And so not only do you need, and these GPUs can join the training run and then they can leave the training run. So by using crypto rails to sort of get the access to the capital that we need to pay for these GPUs, and then using the actual decentralization technology as it was, designed to be, which is something that makes it, permissionless and disintermediated. Those things together allow us to do these massive training runs.
So are you thinking along the lines of like Deepin, where we have this decentralized ability to use, let's say, local compute?
Exactly. Deepin, you can think of something like the Solana one, the Helium. Yeah, exactly. The exact same idea, where instead of it just being someone's computer to run the cell nodes or whatever, you're actually using these GPUs to be able to train a single model all over the world.
And how do people then bring their compute to that to get paid for that compute? How does that mechanism work, or how will it work?
Yeah, well, it's still it's still mostly data centers because there's no way to get around the fact that you need flops, right? There's like a number of flops, and if you know, 10 years ago, the distribution of flops was a lot different. It was actually a lot more dispersed, but the AI world itself in the last 4 years has become very centralized in technology. I mean, go look at DRAM prices for, traditional gaming computers. They cost, what used to cost $200 costs $5,000 now because there's so much demand on the purchasing side for these data centers. So the distribution of the actual flops still is centralized around these data centers. But what is interesting is that if you go to these data centers, they will tell you that at any moment, only like 50% of the GPUs are actually active, actually doing anything, right? And this is I guess you could say like an asymmetry in the market, right? The fact that because people have to sign these long-term leases to get access to the GPUs, there's this imbalance between what's paid for by these companies or these organizations and what the data center says is actually being used. Now, to the data center, it's kind of, it doesn't matter to them if they're getting paid for it, right? But if they're just sitting there idle, that's something that's not doing work. So what we're able to do with our training infrastructure is those idle GPUs, it's almost like mining in Bitcoin or mining in Ethereum back in the day. You've got a GPU. Would you like to turn that GPU into dollars?
It's also like load balancing on the grid as well. It's a similar concept. If you've got excess capacity, how can you use that excess capacity? And can you get cheaper rates for it as well if it's not being used?
Exactly. And so as long as it's like you're getting more than whatever your marginal cost for not running it is, which from the perspective of people who sign leases, that cost is actually zero because you pay full up front as if you were using it 100% of the time, because the data center has to have the power capacity to run all of the GPUs at 100% because they don't know if like everyone's going to turn everything on. So you actually buy the electricity, you buy the space as if you're using it all the time. And if you do or you don't, that's kind of on you. So what we're able to do is take this inefficiency, you could say, in the market, and then leverage it, combine it with the decentralization technology so they can all communicate and there's no central point of failure at all. All of the checkpointing, all of the organization actually is a smart contract. And that's how we're able to train these large models.
And then to have that ability to not have a central point of failure, does it mean you need vast amounts of a larger network of compute and excess compute in case any of these nodes fail?
So that was a big piece of the infrastructure building was the load balancing in the smart contract, basically, to be able to have this, because that's not the normal way training runs run. They're usually these giant monolithic things where, because you have all your GPUs, they all just sort of join together and it works. And so we had to write a bunch of training infrastructure code to make it so that they can come in and come out. And it can speed up or speed down. But the thing about training is that it's not an online function, right? Like it can take longer. It doesn't require like instantaneous latency. Unlike, for example, something like inference, when you're actually running the model, if someone comes to your application and wants to run the model, like it needs to have the capacity immediately to serve them.
And so how does the smart contract work exactly? Because that's another different way of doing it.
Yeah, so the smart contract's job basically is to take the role of assigning all the work and then coming to the consensus on who actually did what they said they were going to. Because, as you can imagine, like all of these, anything where you have permissionless decentralized systems, you're number one fighting against people who are trying to game the system, which is good, right? Because if it reaches an equilibrium in that market, then it's truly, it's truly robust. And so, as opposed to like if you're running a training job in a centralized fashion, any one of your employees could ruin it, could break. Anyone could do anything if they could log on to the computers there. Whereas you have to build a robust infrastructure that's able to be resilient in a fault-tolerant way. So the smart contract's job is basically to take the assignment from the person who created the training run and said, we want to train this type of model on this with this type of data. And its job is to look at all of the nodes that have joined the network, assign, you take this piece of the data, you take this piece of the data. Okay, he said he did this. Did he really do it? He checks this. It just coordinates all of that. But the actual logic itself is a smart contract. So there's no place to go to unplug it, so to say. And this is, for us, this was very much a philosophical point of emphasis because there are a lot of people in the game right now who would use things like regulatory capture to make open source AI illegal. People have been trying to do it now for almost 2 years now, and as far back as only 12 months ago, there was I think it was Senate Bill 1071 in California, which would have made what we do at Noose, just open source AI, illegal. I mean, it was going to put strict liability on open source AI model creators. And what that means is that if anyone used an open source AI to do something quote unquote wrong, the people who created the model would be held criminally liable. And this is something that we don't apply to, say, for example, firearms manufacturers, right? If someone it's been adjudicated, but people tried it. But if you go buy a gun and shoot somebody, the company who made the gun is not liable for that. But there were entities that were trying to instantiate this into the laws so that only the existing players would, who are already established, would be able to take, to run AI in the future.
Yeah, before we go down that whole rabbit hole of why decentralized AI, I just want to go through a couple of other things first. Is what models do you use then? Do you develop your own models or use available models that are, whether it's in Hugging Face or elsewhere? I mean, what do you use for the actual AI?
We started out using other people's models. So we started out using Llama because we didn't have access to the compute that was needed to train everything ourselves. But now we're in the process of training all of our own models from scratch, really being a frontier lab that from start to finish is developing the algorithms, getting the data, doing the full training, and doing all of that open source.
But that's got to be difficult to compete against Anthropic and OpenAI because of they've got the density of talent to create models, or do you not have to be at the very frontier? You just need to be near the frontier.
You need to be near the frontier, but really the name of the company, Nous Research, we really have a strong focus on the research side. And what we've been able to do over the last few years is make a couple of key technical breakthroughs that give us these, what I call these 1,000x efficiency improvements, right? We don't do incremental research. We try to look for things what's going to make the model 1,000 times faster to run, or 1,000 times learn 1,000 times quicker. And we've been by having this as our focus and really looking at the system and saying, okay, if we could solve this one thing, what would give us a huge boost? So a couple of our research endeavors that we've gone down that we publish open have been able to do this. One of them was the actual decentralization optimizer that allowed us to do this training over the internet. We've done other research with context length extension, other really key items. So we have to be scrappy and we have to look for these 1,000x improvements. And it's one of those things where when you hit on one of them, you only have some period of time to do it. And it's just, and people sometimes it can be not frustrating. People oh, we came up with this. And then 6 months later, everyone knows it, but that's the nature of the game when you're in the most competitive technical sphere on the earth.
And the entire game is intelligence per unit of energy. And so, all you're looking for is ways of either increasing the amount of intelligence or the productivity or efficiency of that intelligence, or lower the energy costs. Those are the variables you got.
Yeah, and it's interesting though, because people think, oh, it has AI peaked, but realistically, we have to remember when you talk about intelligence per unit of energy density, this thing up here is running on 30 watts. So your brain is, running, less than 1/100,000th of what it takes to inference, a frontier model, maybe even, several orders of magnitude. So we know it can be done. So there's still, we should be, from a technical perspective, it's amazing what we've come up with, but we still have, we can see, nature is telling us that there's still many orders of magnitude of increases out there if we're able to go find it.
I was talking to Emad Mostak about this, and we came across a different idea, which is, if you look at it now, if I use ChatGPT 5 point whatever Pro, right, it costs me $200 a month.
Mm-hmm.
Right, at $200 a month, that's $2,400 a year for more intelligence than I can create. Mm-hmm. Yes, I might have more visual intelligence and other bits, but generally speaking, it's that is much less than the food bill of a human. So in which
Correct.
Case, maybe it is more efficient. If you think of the whole thing.
Oh, yeah, absolutely.
The whole thing is gazillions of dollars, but running the planet is gazillions of dollars as well. Yes. But the individual units of compute, it's actually pretty cheap. And his argument was, well, it's cheaper than human compute. It's not as perfect in some ways, but better in other ways.
Yeah, absolutely. And the idea that that thing that we have is could still be increased 1,000, could still be made 1,000 times better, could still be made 10,000 times better, means that, that we're not finished. And, there's a place where the thing that's really cool about the field, as many people as are in it and as talent rich as it is, from like a scientific perspective, it's still extremely underdeveloped. If you work in something like, high energy physics, you'll spend your entire career researching, reading on stuff that's already been written. And maybe if you get lucky at the very end, you can make one tiny little addition to like the thought of human knowledge. When we got started at Noose, it was just, I always like to call us the homies on the Discord. It was just me and some people, anime PFPs basically, being like, I wonder if I do this. And wow, it's groundbreaking. And it's like making substantive improvements to the field. So it's very cool to be in a scientific endeavor that's both, that's both challenging, but is still green grass for anyone to come in with an idea and disrupt.
And the next big thing that's coming is obviously going to be this self-reinforcement learning, it's the self-learning of these models. How do you deal with the compute of that? Because it feels like that's going to be another step change in the amount of compute we need, or the efficiency. Yeah,
I do think the self-learning is a big piece, but it actually is I think it's a little bit different because like you mentioned, you go to everyone, when you say, well, I only cost me $200 a month, that's because for you, everyone on the planet is using the same model, right? Like everyone's right. It's the same one. The self-learning thing gets a little bit interesting because you start to think to yourself, like, is it the same single model changing all the time? And is that something that you actually want? Like we like to have our controllability of what we have. We can place this AI in the system and it'll act a certain way. I'm interested to see how self-learning actually will be instantiated, in the world, because if you have models that are constantly learning, that means they're also amorphous in their own sense, right? You who knows what they're going to learn and how they.
At that point, they're truly alive.
Yeah. They will be a facsimile of life for sure, and I think that's a different paradigm that we'd be working with as magnitude as the AI field is right now. You still are in the traditional sort of business SaaS, subscription model. Like it's the same business plan as, getting Photoshop or something, right? Like you could do more, but it's the same one. Under that paradigm, things could get a little bit different. I think that's where the world's eventually going, but, there's still this will be one of these things where, quickly then suddenly kind of, and how it changes the world.
And also it feels that maybe the edge in all of this is going to be the local models that run on anything, because we can run AI through everything from your telephone, the compute in your telephone through to your fridge and everything. All of that is not really addressed yet because OpenAI and stuff and building the giant LLMs, but they're not looking at the localized compute in the same way.
And the one thing I can say is the speed of light is undefeated. And there's literally there's no way to get around it. And that the speed of light directly translates to latency, right? And so if you are, that's why even for Tesla and these autonomous car systems, they have to have the compute local on there because they're making sub-millisecond inferences. And so that's certainly something that I think in the future, once robotics really gets in, that's going to be the thing that kind of brings it out to the masses, because you're not going to be able to have it going to the cloud at every moment to make every decision. So there's going to be some mix of local compute versus these giant centralized GPU clusters that are serving GPT-5 to you right now.
Yeah, and that feels like that's directionally where the next battleground is going to play, because Anthropic and OpenAI and others just really can't compete in that thing because they're focused on something different, but B, no manufacturer of hardware is going to want to have all of its AI compute done by one of these big models because they can just turn it off.
Yeah. I mean, you have to own the stack top to bottom if you want to be able to compete. You can't be dependent on other on other providers, which is interesting for Noose when we do open source models. That's really a selling point. Is you can go to anyone and say, you will be able to download this. You're going to run it on your own infra. You're not paying us a SaaS fee that we can jack up on you at any point. So really, even in the space today, is a competitive differentiator.
And how long before we get? I know it's close, but will we get a localized AI on your computer that does everything, understands every conversation you have, every email you've written, every thing you look at. So it just becomes the extension of you, localized, secure, decentralized. Feels like that's an important part of where we're going.
Yeah,
the thing that Apple could have done or haven't done, bizarrely.
Exactly. Apple could have done, haven't done. Maybe all-time bag fumble, but who knows? I won't count them out yet too. And even like a company like Google, which has such dominance on the browser,
they're getting closer to it.
Yeah. I mean, they are getting closer to it, but
but they don't own the hardware. Google only own the browser, which makes it
and
harder.
so really, I mean, obviously Apple. Well, I'm an Android user, so Google could take me out, but I know I'm in the minority of the world in that perspective. Yeah, so it's really going to be a question of how they're going to roll that out. And from the hardware perspective, how do you do it in a way that is economical? Because already, unless we solve something with like these fabrication plant, it still will be impractical. The amount of RAM that you need and the compute that you need to run a model that is equivalent to what people already expect from the frontier, but running it local, you're still looking at several thousands and thousands and thousands of dollars right now of hardware. And so that's cost prohibitive from putting it everywhere all over the world. I will say that from a pure AI perspective, I think the models that we have now, like if tomorrow we never made another model, we probably have everything we need right now. It's really everything in life is a logistics problem, right? It's like a last mile harness problem. It's not about like, is it capable of doing it? Is how does it hook up to all the myriads of programs? And that's more of an engineering and user experience problem. But, those make the difference between something that's there's the smartest person in the world, is probably like the highest IQ person in the world could have been like, a rice farmer, who never went to school. So this, what can it do versus how is it actually, the harness that allows it to happen is still something that people aren't really working on. And partially in the open source space, you have the incentive problem too, right? Like that's a huge engineering effort to solve. And unless you can, directly monetize it in a way, companies like Google and Apple, rather, which have a direct path towards monetizing it if they can solve it, are a little more incentivized to do it.
So a quick break in your regular programming. If you're serious about your future, grab my free report called Prepare for 2030. I think you've got 5 years to make as much money as possible, and this guide will help you navigate what's coming. The link is in the description. Download it now. Yeah, so why did you go the route of open source decentralized? What was the philosophical reason? What is it that you see that makes you concerned by the centralization?
Everyone who at Noose sort of has their own answer to it. I'll give you mine, but it's not like the company line. For me, it's really born out of a love of technology. So I got started with coding because when I was like 5 years old, a family member gave me a computer and it just like had QBasic on it, right? And there was no internet, there's no way of knowing how it worked, right? So I just had to like type stuff in and figure out how it worked. And my whole experience has been basically that. I've always wanted to. I'm the type of person who just wants to be able to step through the code, to tinker with it, and to be able to work with it, and to build stuff myself. So for me, just hitting an API and getting a response, it's not exciting. It's not interesting to me from like a technical or intellectual perspective. So for me, it was very much just sort of more on that perspective. I want to be able to get my fingers into the technicals and actually work on it. That's what brought me together. Whereas we have people and at Noose as well, who view it very much more from like a political perspective, right? They say that don't want a corporation controlling what they do or knowing what they think or talk about. So everyone has their own sort of bent about why they feel that it's important. There's also like, people who look at it that the information ought to be free. It's even less about like the corporation, but more about like the platonic ideal of information freedom. This could, like the sort of like Linuxy version or like Richard Stallman version kind of, people. So everyone has their own view about why we got here. But what brought us all together is we said, making frontier open source intelligence is something that ought to happen in the world. And there are so many players who are working against that. Let's all coalesce together and try to build this thing.
Yeah, my view on this is if you are going to build the apex intelligence, because it's very close to being smarter than us, when you call it AGI or not, it's a matter of humans admitting they're not the smartest creatures anymore, right? It's as simple as that, which is why nobody wants to say it, because politically it's not a good thing to say. But once you do build apex intelligence, we're seeing it playing at geopolitical level. It's like China cannot have it without the US having it. Europe seems to be ignoring it, which is bizarre, but you kind of, everybody needs to have a share of that intelligence, and it can't just be down to nation states either. Nation states via their big monopolies, OpenAI, Anthropic, etc., that it's going to have to go to the edges, because if not, it's far too powerful. It's just far too powerful to put in the hands of a few.
And if you think about it, we've seen things like this play out throughout history, right? I mean, you can go back really to the invention of something like the printing press, right? So previously you had the ability to, what is like the written word really? It's the ability to like take ideas and send them beyond just your own lifetime, right? Like you're able to immortalize ideas beyond your own lifetime. And that was held within like a closely guarded group of these scribes, and monks were able to read and write and propagate information, forward through time. And at one point, like the printing press radically, decentralized that. It allowed information to be propagated easily through, forward in time through generations very quickly. And this has been like a net positive for society, probably.
There's always the unintended consequences of
high unintended consequences, but we continue
same with the internet, same idea.
And the same idea here is that we have this transformational technology, which we see in a centralized fashion how powerful it can be. So we're sitting right there at like the pre-printing press era of AI right now, right? Like you could see how powerful it is. You could see how incumbents who were able to hold on to this power would be, essentially like immortal. And the rest of us are just, paying homage to that immortality. Or we can diffuse that across all people. And if you do use things like permissionless, disintermediated technologies like blockchain technologies, which don't have a centralized point of failure, even within a nation state, right? Like even within a nation state, I'm sure the United States government, like they really wanted to, could try to shut Ethereum down, but it would be really hard. Or try to shut Solana, it would be really hard. And so, because you just need some people to be running it, and so that to us too, taking that and spreading it out across the world is likely to have the best outcome for the most people.
Yeah, and it can go further because it's more, more people get access. The more people competing, the cheaper it gets, the more people get access. And so nobody can throttle intelligence. And that becomes a really key thing. What is Venice AI up to that's different to what you're doing? Because they're also using blockchain.
Venice is they primarily are on the inference side hosting, so they're about hosting the actual models so that people can come in and run them themselves. We have an inference component of our network as well that we brought up, so we do both training and inference, and probably even more important than that is that we have the AI research lab around it. So we use the crypto rails insofar as they are the correct technology to achieve our goals, which is to have open source frontier AI. And so we use it where it makes sense. And Venice is a great,
for the coordination layer of all of this.
Yeah, correct. Yeah.
And how do you deal with the exponentiality of all of this space? I mean, I knew this was coming, but it's hard for anybody to keep up now with the rate of change. Suddenly everyone's talking about Opus 4.5, like, oh my God, this is AGI for coding. And then next week, Codex, whatever version comes out, it's like, it's impossible.
Yeah, I mean, even for me, it's funny, like a year ago, I've been working in this space for 4 years. Up to 6 months ago, I didn't actually really use models at all. They didn't do anything that I couldn't do, especially as a coder. I will say, like, Opus 4.5 thinking is the first time that me, who's been a practitioner in the space for 25 years now, it can help me. Like it actually, like, it's as good as that. And so even now I'm sort of I've been sort of I've been pilled now. Like I believe like it's coming, but the space is so fast. that's just that's the name of the game. Either you're getting on this cart or you're getting off. We have a group of our researchers really spend a large amount of their time just reading the papers, just trying to stay at the forefront of the wave is what I tell everyone on the team, is that like we need to be at the forefront of this wave. And so whatever it takes to stay at the forefront, we gotta, by hook or by crook, we gotta do it. I'll give you a little side story about just how crazy it's getting though. There's this academic conference called ICLR. It's the premier AI academic conference, right? It was created maybe like 15 years ago, but it is like the top place where papers would go, the top academic conference, right? And like 4 years ago, it got like 1,000 submissions, right? 3 years ago, it got like 2,000 submissions. 2 years ago, it got like 5,000 submissions. And this last year, it got like 20,000 submissions. And what happened was that this used to be operating like an old school academic peer, double blind peer review. Like it was very like institutionalized in the academic sense. But now, because getting a paper into ICLR is like equivalent to getting the highest prestige check mark that you can get in the AI space, there's this giant incentive, for people to get their research ideas into ICLR. So you have these, 20,000 papers, and then the reviewers are like using AI to review their papers. And then like, it's just this crazy like cycle. And it goes to show how like our traditional institutions are not able to handle the exponential that we're currently sitting on.
What about Tau and how that all fits in as well?
Bittensor, yeah. So Bittensor is interesting too. I mean, I think it's a Cosmos chain, right? And we worked on Bittensor a bit. It's a little bit of a different model because with Bittensor, it doesn't actually prescribe what happens on the network, right? And so it sort of leaves it up to chance. And maybe you'll have a research team that comes in and develops something on it, but the correctness of the goodness of what happens on the network is sort of disintermediated from like whether the network is like funding it or not. So it was kind of a interesting alignment, or misalignment maybe, between how some of the incentives have like worked out. And I know they've changed a lot of it since then. So Bittensor is much more like neutral in the sense, right? Like it's just the blockchain layer. It would take the place of Solana on our network or something like that. Whereas what we're building with Psyche is really purpose built to make frontier open source artificial intelligence.
And how are you going to deal with agents? Because this gets really interesting as well. Having decentralized autonomous agents with payment systems.
Yeah.
It's quite the world we're about to walk into, right?
Yeah. Well, so I'm very interested. We're very early on, like X402 and some of these other systems that are, trying to solve this problem. I still, the agents sort of has two sides to it. One is you need to have the research, and this is the area of like, if you were to walk in, Anthropic, go to OpenAI, like what is like the frontier, like what are people really researching right now? It's these long horizon, agentic tasks. That's like the thing that needs to be like solved. And we're solving it variously through different methods of RL and context, forever contexts. So that's why like right now, the hot thing in like the true AI model space is like infinite context length, right? Like how could we, because with the idea being that if we had infinite context length, well, then maybe the agents can go on forever. But, that's sort of like the technical thing that everyone's searching for. And the core bottleneck there is the fundamental technical operation of attention. So like attention, which is from the paper, attention is all you need. It's the core operation inside of the transformer. It scales quadratically with the size of the input. So as you have more and more and more context, the compute you need grows quadratically. So everyone in the technical space now is working on these sub-quadratic attention mechanisms. So attention mechanisms whose computational cost scales at least sub-quadratic. So not necessarily linear, but maybe like n log n, n log n, something like that. So everyone's working on these. So there's the technical side that needs to be solved. But then even once you solve the technical side, like we talked previously about the harness, that's really like the question is, where do they fit into the world as it exists today? Certainly we can have agents that run, but I think there's a difference between an agent that does something for you, which is like you tell Claude, go change this code and work on this. That's just, an agent working on behalf of a single person's command. Will be even more interesting, I think, in the future is if you actually have these systems interacting with each other, like agent-to-agent communication decentralized.
We are not far away from having an autonomous agent that has a task, which is to make money, whatever it is, and it figures out how to do it and what to do. And people will spin these up all of the time. They'll spin themselves up eventually as well. And it becomes, well, that's an extraordinary world, because then we've got new economic actors acting under different, whether it's profit motives or whatever motives they have.
The question is, what is the edge there, right? Like, what's the differentiator in that situation, right? So if everyone's using Claude Opus 4.5, so it'll be interesting to see in that space.
Well, that's where open source makes sense, because different people can focus on different component parts for different parts of this, particularly in the agent space where there is high variability between tasks.
Yeah, and then your edge, so to speak, is how you're able to take these open source models and actually tailor them to a specific modality. And that will be, and it'll be interesting to see where that ends up, because it's no longer that people have said before already, like the idea, this is the age of the idea guy, right? Like if you've got an idea, you might be able to like instantiate that change in the world using these agents, when previously your idea was infeasible because you weren't able to go get the employees, get all the other things that are needed to like actually bring it about in the world.
Yeah. And also, we saw this whole kind of race in the financial world with high frequency trading. It was another way where people realized that, okay, we can get an edge by doing a specific thing, which is latency. And if we can do latency plus a good model for trading prices, we do it at scale, and it spun up tons of different people, made a huge impact on financial markets. And we're going to see the same kind of thing, because there'll be profit motives by training an agent to do certain things. So then there'll be a massive capital war of injecting money into those things. And what you actually end up driving is efficiency.
Yeah, and companies like Jump, which completely revolutionized the space, and in that their edge is still sort of all in-house, right? So it'll be interesting to see if we continue to see like what is the next generation of organizations that are spun up that have whatever talent that is to be able to go solve problems. Whether is it more a McKinsey style thing where you go to a place and say, oh, tell us what you want done and we'll get it done? Or is it more of like a Jump thing where like we're just going to try to hoard all the money into ourselves and be a firm like that? It'll be interesting to see which model wins out.
Yeah, or whether agents themselves, because they're just going to end up being companies in their own right, but they don't even need to register as a company. It's just this bizarre world where these AI agents are creating economic value themselves, capturing the value, spending it on whatever they spend it on, compute or whatever else. It's bizarre.
Yeah, what are the calories in that system, right? Compute, electricity, yeah. But, it's interesting because this brings about, what are the second, third order social effects of something like that? Like it's difficult to predict, and it's not worth often to try to prescribe the technology based on your imagination. Like, oh, well, we can't do this because of what, this might happen, which might happen. Whenever you multiply probabilities, things get small very quickly. But, just sort of armchair thinking about what does the world look like where like large amounts of the economic activity have been replaced by autonomous agents. It's just, we're thinking about.
Yeah. I mean, what I get to in all of that is we cannot compete on intelligence as humans.
Correct.
It's not possible, and it will not be possible beyond probably this year.
Yeah.
That's done.
Yeah.
So what can we do? Well, the only thing we can do is actually be human.
Yep.
Right. I just think of us as nodes of compute anyway, whether it's computing consciousness or whatever it may be. And human life experience is the thing that creates that compute. And so we just continue to do human things, and there will be value to being human, I think.
And, it's interesting that all of these, the AI systems that we put out, they put out words, LLMs. Those words are only special insofar as they have meaning to us as humans, right? So if you think about it from like a math perspective, there's nothing about the English words that are like special that are coming out. It's only because we look at them and prescribe meaning to them within our own experience that it becomes valuable at all. So when we make these AI models, we aren't making them to be smart, because like, well, they are making me smart, but like there are completely separate languages, completely separate idea modalities that these AIs could have learned from like in an alien world that like would mean nothing to us, right? And we'd be like, it would be indistinguishable from random noise. Even if like the exact same computation was going on and it was threading this very difficult needle of reasoning or whatever you want to call it, the outputs could be completely incoherent to us and we wouldn't recognize them or value them for anything. But
that is going to happen.
It probably will happen, yes.
They will use their own language that's more efficient mimetic pathways than human language. I mean, there's no reason for them over time to not develop their own.
Correct. Unless we as humans, have some sort of forcing function that keeps them wanting to propagate the human mimetic institutions. Yeah.
It can absorb it, but it doesn't. We can be input, but it doesn't. We don't have to be the full consumer of its output, is the point. AI to AI can speak whatever language it creates that is more efficient, but when it gets input from us, it gets it in.
Oh, I got to talk human. I got to talk dumb human now, huh?
Yeah, that's right. So go out a few years. We can't go out many years in all of this because it's just too much. But where is the world, and where are you guys, Nous Research, in that world?
I think we'll continue to see in the next
now,
few
I expect you to be wrong because everything's changing so fast, but so I'm not holding you to it.
Yeah.
Well, it's just an interesting thought process.
Anyone who tells you for sure where it's going to be, if they really knew, they would not be saying it. But my guess is in the next year, 2 years, you continue to see the end game version of the current paradigm, right? So what's the end game version of the current paradigm? You have the massive infrastructure build out at the nation state level. Right. So you have to be able to build all the data centers and then also fabricate the chips, in-house everything yourself. I think that from a Western perspective in the United States, we're doing a really good job on the building infrastructure side and obviously on the chip side. And our centralized players are doing a very good job. On the Chinese side, their infrastructure on the building side with the chips is behind, but on their centralized players, they're only like maybe a little bit behind. But their open source players are actually even like better than our open source, than the Western open source players. But I think we continue to see this build out from over the next few years, and it'll eventually potentially end up with some sort of like geopolitical situation surrounding the fabrication of like how the chips and access to the materials that are needed. So I think on like the macro side, that's how it looks like. On the tech side, I think you will continue to see lots of things people can use AI all over, and it won't look any different from like the economic model at first. So like people are still going to have jobs. People are still going to go into like the world that you look at is not going to like look totally crazy different. But if you like peel the veneer underneath, you're going to have, you already see it before. You have lawyers copying their legal arguments into the AI, which will then go to a judge, which is putting it into an AI. And how we sort of normalize that in society, I think is something that will have to be dealt with, because it's like you said before, previously, like even a year ago, you could say, well, you can't use AI to make these decisions because how could you? But like in a year, we're going to have these, like I said, even I had my own like aha moment with Opus 4.5 thinking more and more the people are like, it's almost like wrong not to use these models to do it, right? Because like it was actually better at it than all of us. Like we can't, like no one's going to want to play this game of like, people always want to, you always will use the best thing, the fastest thing. There's no way to like get that milk back into the carton once it's spilled, right? So in situations where it's clearly incredibly better at almost everything, I think then you'll start to see like, how are we going to organize this from a social perspective of using it to make more and more critical decisions within the pathways of people's everyday lives. And I think that's something that, you've seen already. There's these like anti-AI movements, these pause AI movements, or the
that's going to be a big political movement.
It's going to be a real thing, and I think people underestimate, when people read science fiction stories, again, they see the science fiction stories always have, like, you open it up and on page 1, it's like, oh, the world's like this. But to get to that point, people forget that, like, we had to go through everything before there. And at every stage before there, there's social things happening in the world that could change the direction of the technology itself to actually get to that point. And I think people are undervaluing like what will happen over the next years as these technologies start to like really infuse every aspect of life, up to and including like the predictable and obvious backlash that will come from different segments of society.
Yeah, and let's go into that backlash, because that's interesting, because I see the same thing. I see the accelerationists and the decelerationist, and that becomes the political struggle, not capital versus labor that was the traditional one, but it becomes this. And you can't, if you have open source, you can't stop it.
Mm-hmm.
Right? So there's no way you can just go to, say, to Anthropic and OpenAI and Google and stuff and Meta and say, listen, you're not going to allow this.
Mm-hmm.
Or we're not going to allow you to go further because A, China will do it.
Mm-hmm.
And because of open source makes it impossible to shut down, which is why the internet proliferated and crypto proliferated. That's great. But the unintended consequences are also, we have no fucking idea what we're building here.
I think ultimately, yes, that is the idea that we're here. But like, I find it the decelerationist are a bit disingenuous because their negative view is, also just a fantasy, right? They're presuming to see the future and how this technology will work out, and I could basically split the decelerationist into like you have like the climate focused ones, which like the energy. I ascribe very little, weight to that because we've always more demand has always led to increased efficiency, right? Like we only needed to get coal because wood wasn't good enough. We only needed to get nuclear because coal wasn't good enough, and all these things. So whenever like people are like, it's going to use up all the electricity, I'm like, perfect. That's going to be the thing that forces us to go find 100x better efficiency.
Well, you can see Elon with he's moving on beyond Kardashev scale 1 to scale 2.
Yeah, if we didn't have AI systems, we probably would just sit around and burn all the oil that we have, right? It's the easiest. People are going to take like the easiest path we have. But what if like all the oil in the world doesn't get you even near what you need, right? Then you're like, oh shit, now I have to go solve nuclear. Now we have to, and like ultimately, so to me, those things are, very nebulous. What about the future system? What is it going to paperclip the world? All these other sorts of problems. The problem with that is, A, like you said, people are just going to do it anyway. Someone's just going to do it. So when you live in this world where it's like that, you have two choices here. You can bury your head in the sand and do nothing about it, or you can take agency and try to solve it. And so that's what we do at Nous Research. And we said, we're going to try and solve it, and we're going to build decentralized artificial intelligence that is human-centric, puts human values into it, and we will do our best to create the best future of the world.
And yeah, my final thought on this is, obviously there's fear. People don't like change. Okay, I get that. Where I get to with the whole paperclip or is it going to kill us is, it's like, would we kill all species on the planet? No. Why? Because they add some value to the global ecosystem that makes us. We couldn't exist without it. And, again, I think of all of these things as nodes of compute, whether it's plants, whether it's animals, whether it's everything. And they all add to this thing that creates humans, that allows them to have knowledge. We're kind of compression files of a bunch of other stuff that went before us. This is just a compression file of human current knowledge. It will change over time and build its own knowledge. And it can't do without humans. Because without humans, it doesn't get 8 billion people adding to its knowledge base in real time by experiencing life, writing about it, talking about it, and doing all the things. It would not make sense to do that yet. I mean, even when it gets to ASI, it still doesn't, because that just becomes a network of nodes of AGIs that form into something big. It's all the same. It's all networks all the way up, all the way down.
And to sort of, at any moment, everyone in time has thought that their specific space and time is like the special privileged space and time, right? And like for us to now, it's kind of like the ultimate ladder pull, right? To like say, all right, now we're at the end, we're going to set the bar as like whatever we got right now is the true ideal of how human society is supposed to work, and we're not going to allow any progress. I mean, I said earlier about multiplying probabilities, right? All of these situations about in the future are all about saying, well, if this, then that, then that, then that, then that. What we've broadly seen is what always happens if people optimize for their local minima. You create coordination systems where people optimizing for their local minima creates the global maxima for everyone. So as long as you get that system right, it solves itself, from simple reproducing chemicals or in a vat down by the 600,000 years ago to complex multicellular life. All of it was local optimization of minima towards a global maximum.
Yeah, it's a local coherence that forms larger networks of coherence, which forms the thing. So
yep, and that's what we're working on.
I love it. Brilliant. Anyway, that was a great conversation. Really enjoyed it. Really excited to see where you guys get to with all of this. It's going to be a hell of a few years.
Yes, I agree. NooseResearch.com for anyone who's interested in learning more about what we do. And really enjoy the conversation.
Fantastic. So look, another fascinating discussion and interview about where this is all going with AI. It's so hard to keep on top of all of the component parts, the battles that are taking place, who's doing what where. But that's what we try and do here at The Journeyman, to make sure that nothing catches us by surprise and we understand where the world is going. So anyway, I'll see you next time. So you obviously like this video enough that you've got to the end. That's quite a big task. But listen, do me a favor, hit the like and subscribe button, and also check out what video's next, because I think you'll love it. But if you want even more, and when I'm talking more, I'm talking about member-generated ideas, incredible alpha, research, everything there to help you in your journey, just head to realvision.com/join for the best financial intelligence out there and the pure alpha that's within the platform.